Hi all, good morning. Today we can discuss some of the important topics in first unit. Okay, so in first unit, linear search and bubble sort, algorithm, flowchart, pseudocode. Actually, different in your older scheme also, these two topics very important. Okay, linear search, algorithm, flowchart, and the pseudo similar to this one, bubble sort. So today we can discuss this linear search, how to write the algorithm, flowchart, and the pseudocode for the linear search. What was that linear search? Linear search. What is searching? Searching means we are finding an element that is present in a list. Okay, that means you will get a list. Okay, list of elements. From that list, you need to find a particular element, whether it is present in that list or not. You need to find that. If it is present, then you need to tell the position also. Okay, you can say that the given element is present in the particular list in the particular locations. Okay, likewise, you need to produce the output. So how we will write the algorithm, how we will draw the flowchart, and how we will write the pseudocode for that. That we can discuss. So sometimes the question will ask, write an algorithm with a suitable example for linear search. Then you need to write the example also. Okay. So here is an example. So in this example, there is a list, and the list contain different elements: 65, 20, 10, 55, 32, 12, 50, and 99. In that, we need to find an element. So this is the search element. So in this list, we need to find the 12. That means whether that element 12 is present in this list or not. That is our aim. Okay. So how we will perform this linear search algorithm? How we will perform this linear search algorithm? So first for that, we need to compare the first this element. That means search element with the zeroth element in this list. Okay, zeroth element. Okay, so first we need to compare that this 12 with the zeroth element, whether the zeroth element in the list and the search element, that is 12s, are equal or not. Okay, if these two are equal means the given element is present in this list. Okay, else we can say that else we need to compare this list to this element with the another, that is next element in the list. Okay, here the zeroth element is 65, our input is 12, so there is no matching. Okay, there is no matching. Then what we have to do? We need to compare the search element with the next element in the list. Okay, we need to compare the search element with the next element in the list. Okay, here the next element is 20. Okay, so we are comparing 20 with the 12. Here also there is no matching. Okay, there is no match. Then what we have to do? We need to compare the given element with the next element in that list. Here it is 10. 10 and 12. There is no matching. Okay, so then what we have to do? We need to compare the key element with the next element. Here it is 55. There is also no matching. Okay, because 55 and 12 both are different numbers. Okay, so in that case, what we have to do? We need to search, we need to compare the next element in that list with our search element. So here also there is no matching because it is 32, this one is 12. There is no matching. Then what we need to do? We need to compare next element with the our search key. Here both are equal, then we can see that the given element is found in this position. Okay, the element is present in the list with this position. Okay, so this is the way how we will perform the linear search algorithm. Okay, this is how we will perform the linear search algorithm. Okay, so this is the example. From this example, we need to develop an algorithm. Okay, we need to develop an algorithm. So, how we will write the algorithm? What will be the first step? Anybody, you tell me in your own words how we will write the algorithm. Tell me the first line. Logic I have explained you clearly. That means, first we need to read the element. Read the list. Then we need to read the element. Then next step, we need to compare the search element with the first element in the list. If both are matching, then we can say the given element is present. Else, we need to compare that element with the next element. If they are equal, then given element is present. Else, we need to compare the search element with the next element in that list. Likewise, you need to compare all elements, okay, with the search element. If you are not to find any match after traversing the whole list, then you can say that the given element is not present in the list. Okay, if suppose any of the position, if you are finding any match, then you can say that the given element is present in that particular list. Okay, so that is the procedure. So from this procedure, we need to develop an algorithm. We need to write draw a flowchart. Then a pseudocode also. It is very easy to write the pseudocode also. So how we will write the algorithm? Tell me it in your own words. Anybody? Aditya, Vinod. How we will write the algorithm? Tell me the procedure. Then we can make it as an algorithm. Aditya. Aditya, Vinod. ഞാൻ പറയുന്നത് കേൾക്കുന്നില്ലേ? Okay, tell me the procedure. You just tell me the procedure first to perform the linear search. I have explained you everything. You tell me that. Anushree V.
Yes, sir.
Okay, tell me the procedure.
Hello.
Tell me.
Start. Step 1 to start.
Start. Okay, step 1, start. That is correct. For every algorithm, you need to write that step 1. Okay. Then?
Read the number.
Which number we need to read?
Search element.
Okay, read the search element. Correct. Then
Compare the number with the list, with the numbers of the list, and if it is matching,
how will you compare that list? How will you compare the whole elements in a list with a single element?
Compare the element with the first element of the list.
Yeah, correct. First element in that list. Then correct answer, correct. Then
second
what is the next step?
Third element.
Likewise, you need to compare.
If it
Okay.
If it is matching, show something display element found at the index.
Okay, correct. Then,
and if it is not matching, the search element is not present in the list.
Okay, correct. ആൻസർ ശരിയാണ് കേട്ടോ. ഓക്കെ, അപ്പോൾ നമ്മൾ എന്താ ചെയ്യേണ്ടത്? ഫസ്റ്റ് സ്റ്റെപ്പ് ഒക്കെ നമ്മൾ ആദ്യം എഴുതുക. നിങ്ങൾ എപ്പോഴും സ്റ്റാർട്ട് എന്ന് എഴുതുക. റീഡ് ദ സെർച്ച് എലമെന്റ് ഫ്രം ദ യൂസർ. Okay, combine the search element with the first element in the list. Okay, if both are matched, then display given element is found and you can terminate the operation. If both are not matched, then compare the search element with the next element in the list. Okay, you need to repeat these 3 and this 4 until what compared with the last element in the list. Okay, if last element is also doesn't match, then you can display that the element is not found, you can terminate. Okay, if you find any match in a particular position, then you can say that the given element is found. Okay, so this is a simple algorithm. Okay, for performing the linear search operations. Okay, so this is the algorithm. Then you need to before writing that here you need to write a start and the last step you need to write a stop. Okay, here I have not specified that for every algorithm first step is the start step and last step will be the stop or end. Okay, okay. Then from this algorithm you need to draw the flowchart. Okay, so this is the flowchart for that algorithm. So first one is the start statement. Okay, so for start we will use this symbol. Then parallelogram for reading the data input key. Then here we are using a count I is equal to 0 because we are traversing from 0 onwards, because this is the best way for implementing array while you are implementing program. Okay, so I is equal to 0. Then while I less than n, you need to compare the array element with the key. Okay, if any matching is occur, then you can print the location that the element is found like that. Okay, if there is no matching, then you need to increment the count. Then repeat the same process. Okay, repeat the same process. If you traverse the total array list, then if you are not finding any matching, then you can print that the element is not found. The element is not. Finally, you can stop. Okay, you can stop the algorithm. Sorry, flowchart. For start and stop, we will use what these things. Okay, then this is the parallelogram, because if you are performing any input or output operation, so parallelogram you have to use. Here also you need to use parallelogram. Okay, because this is an output statement. Parallelogram. Display and show also you need to use parallelogram. Okay, so any mathematical or initialization process, you can use this rectangle. Okay, then this is a decision making statement. Okay, so you can use diamond box. This also decision making statement, so you can use diamond box. Here also a decision making statement. Okay, so this is a simple flowchart for performing linear search algorithm. Then last one is pseudocode. Okay, pseudocode means you just write the algorithm in a program manner. Okay, that means first we need to input a key, then we need to initialize the index to 0. Then while index is less than size of array, you need to compare. Okay, in that time you need to compare the array index equal to the key. Okay, if it is equal, then what key print is found in that location, then you can skip the loop and exit. Else you need to increment the index and you need to perform the same operation repeatedly. Okay, if index equal to size of the array and if you are not finding any matching, then you can print the key is not found. Okay, so this is a pseudocode. Actually, you have to study pseudocode, flowchart, and this algorithm and exam, because it is very important. Because for every university question, order scheme and all, this linear search program also there that we can discuss in the next unit while revising that. Okay. So linear search algorithm. What was the algorithm? Read the search element, compare the search element with the first element in the list. If both are matched, then display given element is found and terminate. If both are not matched, then compare the search element with the next element in the list. That process we need to repeat. Okay, either you will get an element or the list will be that means if the last element the list doesn't match, then display the element is not found. So that is the linear search algorithm. Okay. ഇത് ഇമ്പോർട്ടൻ്റ് ആണ്, പഠിക്കണം. അൽഗോരിതം പഠിക്കാൻ നിങ്ങൾ ഈ എക്സാമ്പിളും പഠിക്കുക, ഫ്ലോ ചാർട്ടും പഠിക്കുക, അതുപോലെ തന്നെ യൂണിറ്റ് സ്റ്റഡി ചെയ്ത pseudocode. Similarly, another algorithm is there, that is bubble sort. Bubble sort. Okay. What was sorting? What is sorting? Sorting means what? Anybody? What is sorting? Anybody? What is sorting? Okay. Arranging elements. Correct. Arranging. Okay. We are arranging elements in a particular order. Okay. So that is what the sorting. You can perform here sorting in two ways. One is ascending order sorting and descending order sorting. Okay. So first we can see an example, then we can discuss the algorithm, then flowchart, and last one we can discuss the pseudocode. Okay, here for bubble sort also you need to study algorithm, flowchart, pseudocode in the first unit. Okay, so how we will perform the sorting? Suppose this is the list: -2, 45, 0, 11, and -2. So these are the list. These are the given list. So in this list you need to perform the sorting process. Okay, you need to perform the sorting process. How we will perform the sorting process? So for performing sorting, what you need to do is you need to compare the first two elements. Okay, you have to take the first element and you need to take the second element, compare it this. Okay, compare this. If first element is greater than second element, then you need to exchange this element. Else, you no need to perform any operation. So that is the logic. Okay, so first you need to compare the first element with the second element. Okay, first element here it is -2 and here it is 45. Okay, so you need to compare the first element with the second element. Then check whether the first element is greater than second element. If first element is greater than second element, you need to perform a swapping operations or exchange the content in these locations. Here, -2 is less than 45, then no operation. You don't perform any operation. No need to perform any operation. You just move your comparison with the next two elements, that is 45 and 0. Okay, next two elements, 45 and 0. Here, 45 is greater than 0, isn't it? Here, in this case, 45 is greater than 0. Then what you have to do? If the first element is greater than second element, you need to swap these elements or you need to exchange the contents in this location. Here, 45 is greater than 0. You need to perform the swapping operation. That means you need to move the content 45 into in this location and 0 into this location. Okay, So this is the list. After swapping, you will get the list. -2, 0, 45, 11, and -9. Okay. Then again, you need to compare the next two elements. Okay. Next two elements, that is 45 and 11. Okay. 45 and 11. And you have to check whether 45 is greater than 11. Okay, 45 is greater than 11. Here it is correct. Okay, 45 is greater. Then what you have to do? You have to swap the content. That means you need to move 11 to here and 45 to here. So this is the elements. After swapping, you will get this element, that is -2, 0, 11, 45. You have exchanged the content. Okay, 45 -9. Okay. Then after that also you need to compare the next two elements, 45 and -9. Okay, 45 and -9. Here -9 is less than, 45 is greater than. Then what you need to do? You need to swap the content. So -9 will come here and 45 will come here. So you will get the list, that is -2, 0, 11, -9, 45. Okay. So after traversing the whole list, you will get the largest element in the last position. Okay, in this first step. Okay, in the first step, after traversing the whole list, you will get the largest element in the last position. Okay, so largest element will be in the correct position. Now, after performing the first step, that means 0th step, you got the largest element in the last position. Again, what you have to do? You have to sort the remaining elements. Okay, again you have to sort the remaining elements. These elements you need to sort. And you need to find the second largest element and place it in the second largest position. Then again you need to perform the remaining list. Then you need to find the third largest element, place it into the third largest position. Likewise, you need to place all the elements in its exact position. Then finally, if you traverse the whole list, you will get a sorted list. So this is the logic. Okay. So here in the step 0, we got the largest element in the last position. Okay. Then in step 1, you need to perform the same operation. Okay. To find the second largest element. Okay. To find the second largest element. Okay. So for that, you have to perform the same operations. What you have to do? Compare the first element and second element. Here it is -2. This one is 0. Tell me which one is lesser element, -2 or 0? Nandana Raj. Nandana Raj. Nandana Raj.
Sir.
Okay. Which one is the smallest element in this list? -2 or 0?
-2.
-2. Then what do we have to do? Do we need to swap or not?
സ്വാപ്പ് അല്ല ഒന്നും ചെയ്യണ്ട.
ഓക്കെ, കറക്റ്റ്. ഒരു ഓപ്പറേഷനും ചെയ്യണ്ട, സെയിം അതുപോലെ തന്നെ. Then next you need to compare 0 and 11. So tell me the answer. You are comparing 0 and 11. Then what will happen?
0 less than 11.
0 less than 11. Then what do you have to do?
നെക്സ്റ്റ് എലമെന്റ് അടുത്ത രണ്ട് എലമെന്റ് ചെക്ക് ചെയ്യാം.
Okay. Then next element is 11 and -9.
-9 is less than 11.
-9 is less than 11. Then what do you have to do?
സോർട്ട് ചെയ്യുക.
Sort, actually throughout the process it is sorting. In sorting ഓരോ സ്റ്റെപ്പിലും നമ്മൾ എന്തോ ഒരു ഓപ്പറേഷൻ ചെയ്യുന്നില്ല. ഈ ഓപ്പറേഷൻ എന്താ പറയാ? ഇവിടെ സപ്പോസ് ഫസ്റ്റ് എലമെന്റ് ഈസ് ഗ്രേറ്റർ ദൻ സെക്കൻഡ് എലമെന്റ്, then we need to perform a particular operation. What is that operation?
ബബിൾ സോർട്ട്.
Bubble sort is the whole process. Okay. ഈ കംപ്ലീറ്റ് പ്രോസസ്സിനെയാണ് നമ്മൾ ബബിൾ സോർട്ടിങ് എന്ന് പറയുന്നത്. അപ്പൊ അതിൽ ഒരു ഇൻഡിവിജ്വൽ സ്റ്റെപ്പ് ഉണ്ട്. അതായത് 11 ഈസ് ഗ്രേറ്റർ ദാൻ -9.
സ്വാപ്പ് ചെയ്യാം.
ഓക്കെ, കറക്റ്റ്. സ്വാപ്പ് ചെയ്യുക. സ്വാപ്പിംഗ് മീൻസ് വി നീഡ് ടു ചേഞ്ച് ദ കണ്ടന്റ്സ് ഇൻ ദോസ് ലൊക്കേഷൻ. ദെൻ ഇത് രണ്ടും സ്വാപ്പ് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് എന്താ കിട്ടാം?
-9 അപ്പുറത്ത്
ഇവിടെ കിട്ടും, 11 കിട്ടും. Then do we need to compare 11 with 45?
നോ, വേണ്ട.
എന്തുകൊണ്ടാണ് വേണ്ടത്?
അത് 45 11നെക്കാട്ടും ഗ്രേറ്ററാ.
That is not the reason. Because 45 we already sorted in and placed in its exact position in the previous step. അല്ലേ? ഈ സ്റ്റെപ്പിൽ ഓൾറെഡി ഇതിനെ നമ്മൾ അതിന്റെ എക്സാക്ട് പൊസിഷനിൽ പ്ലേസ് ചെയ്തില്ലേ? ഇനി വീണ്ടും കമ്പയർ ചെയ്യേണ്ട ആവശ്യമുണ്ടോ?
No.
No. Now you got the second largest element. Okay, correct. You got the second largest element. So again you need to perform the operation. Okay, you need to perform the operation. Same operation. Tell me what we have to do in step 2. പറഞ്ഞോളൂ.
-2 0 ചെക്ക് ചെയ്യാം.
ചെക്ക് ചെയ്തു. Then
അപ്പോൾ അത് കറക്റ്റാ. -2 0നെക്കാൾ ലെസ്സാ.
Okay, those are in the same order. അല്ലേ? അപ്പോൾ no need to perform swapping. Then what do you have to do?
നെക്സ്റ്റ് സ്റ്റെപ്പിൽ 0 -9 കമ്പയർ ചെയ്യാം.
Okay, 0 and -9. Then
-9 0നെക്കാൾ ലെസ്സാ.
okay, then
സ്വാപ്പ് ചെയ്യാം.
swap ചെയ്തു. Then -9 0. Then
നെക്സ്റ്റ് സ്റ്റെപ്പ്.
അപ്പൊ ഈ സ്റ്റെപ്പ് അവിടെ സ്റ്റോപ്പ് ചെയ്യാം. കാരണം എന്താണ്? ഇപ്പോൾ 11 ഓൾറെഡി പ്ലേസ്ഡ് ആണ് അല്ലേ? Then 0 ആയി അടുത്ത്. നെക്സ്റ്റ് we need to repeat the step 3. In step 3 what you have to do?
-2 -9 നോക്കുക. അപ്പോൾ -9 -2നെക്കാൾ ലെസ് ആയതുകൊണ്ട് സ്വാപ്പ് ചെയ്യാം.
Okay, correct. -9 -2. Okay, so -2 will be in the exact position. ഇനി -9 ഫൈൻഡ് ചെയ്യേണ്ട ആവശ്യമുണ്ടോ? ബിക്കോസ് ഇഫ് 5 എലമെന്റ്സ് ആണുള്ളത്, 4 എലമെന്റ്സും സോർട്ട് ചെയ്ത് കഴിഞ്ഞാൽ ഓട്ടോമാറ്റിക്കലി 5th one will get the exact position. അല്ലേ? ഓക്കെ, അപ്പോൾ നമ്മൾ സോർട്ട് ചെയ്തു. കറക്റ്റ്. So this is the process. Okay, so this is the process. What we have, എന്താ നമ്മൾ ചെയ്തത്? First we will compare the first element with the second element. If first element is less than second element, we are not performing any operation. We will keep the list as it is, and again we will compare the second element with the third element. Then again we will perform that. That means second element is greater than third element. If it is greater than third element, we have to perform the swapping operations. Okay, so that process we need to repeat. For step 0, we need to traverse. Suppose the element size is 5. Okay, suppose the element size is 5, then we need to traverse the j from 0 to 3. Okay, in step 0, if total size of the element is 5, then you need to traverse the j from 0 to 3. And in step 1, you need to traverse the j from 0 to 2 only. Okay, in step 1. Then in step 2, j from 0 to 1 only. Okay, then in step 3, j 0. So this is the logic. From this logic, we need to develop an algorithm. Okay, so before writing that algorithm, we can write the logic for that. Okay, so here two iterations are there. Right. In step 0, J is traversing from 0 to 3. In step 1, J is traversing from 0 to 2. In step 2, J is traversing from 0 to 1. Like this, step 3, J is 0 only. So two iterations are there. Okay. So for that, we can represent the first iteration and the second iteration. In first iteration, what we are doing? Okay, we will start from the first index, compare the first and the second elements. If the first element is greater than second element, they are swapped. Then now compare the second and the third element. Then swap them if they are not in order. That process has to repeat until the last element. Okay, so that is the first iteration. Likewise, you need to perform another iteration. That is, the same process goes on for remaining iterations. After each iteration, largest element among the unsorted element is placed in the list. Like, whether first iteration, first largest element is placed either. Then in the second iteration, you have placed the second largest element. Then in the third iteration, you have placed the third largest element. Fourth iteration, you have placed the fourth largest element. Here only 5 elements are there. So fifth element will be automatically conveyed to the x-negative position. So this is the procedure. This is what I have written here. Okay, first iteration and the remaining iteration. Next, what are the steps? Okay, first starting, we need to starting the first element, index is equal to 0. Then compare the current element with the next element in the array. If current element is greater than the next element of the array, swap them. If the current element is less than the next element, move the element in the next step. Then this process we need to repeat. So that is the logic. Then this is a pseudo code for that. Okay, pseudo code for bubble sort. Suppose there is an array is there. Okay, then first we need to traverse for I is equal to 1 to n. Okay, then from that we need to traverse j is equal to 0 to n minus I minus 1. Okay, so for each traversal, you need to compare if a of j is greater than next element a of j plus 1. Okay, if a of j is greater than a of j plus 1, what do you need to do? You just to swap it. Swap a of j, comma a of j plus 1. Okay, swap a of j, comma a of j plus 1. Okay, then if you complete the total 2 iteration, you will get the sorted list. Okay, so this is the pseudo code. Then this is the detailed algorithm. Start, read the element, initialize I is equal to 0. So this is for reading the elements. Okay, first we need to read the element. Then only you can perform the sorting operation. So this is for reading the element. If I greater less than n, then go to step 5. Read the number of elements. Okay, I is equal to I plus 1, then go to step 5. So these steps are used for reading the element. First you need to read the element. Then you are going to perform the sorting operation. Okay, so this is the step. If I less than n, what you are doing? J, you will create another variable, j is equal to 0. If j less than n minus I minus 1, go to step 11. You can stop. Else what you have to do? You are comparing the jth element with the j plus 1 element. Okay, if jth element is greater than j plus 1 element, you need to swap. So this is the procedure for swapping. For swapping, you will use a temporary variable. Temp is equal to a of j. First, you will copy the value of the a of j into temporary variable. Then you will move the a of j plus 1 value to a of j. Then finally you will move the temporary value of that copied, that is value that is present in the temporary variable to a of j plus 1. That process you will repeat. Okay, so this is the detailed algorithm. Suppose they are asking you to write the detailed algorithm, then you can write this. Suppose they ask you to write the algorithm in 3 marks, then procedure you can write this is enough. Okay, first iteration and the second iteration. So depending upon the mark, you need to write the answer. Okay, suppose if they are asking 6 marks question, you need to write the detailed algorithm also. Okay, if a 3 mark question, first this is enough. Suppose they ask you to write the answer for 10 marks, then you need to write the example also. 10 marks or 8 marks, then you need to write example also. Okay, example. You can write this example. Okay, then proceed here, then pseudocode, then detailed. And this is the flowchart. This also we have discussed that. Bubble sort start. Okay, start. Then so instead of writing starter, you can perform the name, place the, you can write the name of the algorithm also. That is also allowable in flowchart. But generally you will write a start. You can write here start. Okay. Then set the length of the array, that is n. Then you are comparing array of j with the array of j plus 1. If jth array is greater than j plus 1, you are performing a swapping operation. So for that you can use a rectangle. Okay, after swapping you need to increment the j value. Okay, so that process you will repeat. Okay, so until j greater than n minus I minus 1. Okay, then that is for first iteration. Likewise you need to perform different iteration. So for that you can use another timer. Okay, I less than n minus 1. So finally you can stop. So you will get the ordered sorted array. You can write stop here. Okay, so this is the flow chart. You already studied this. Okay, this is only a revision. So for writing answer, depending upon the marks, you need to write the answer. Okay, suppose they are asking 10 marks for writing flowchart with an example, then you need to write the flowchart and you need to write the example. Okay, in that case, no need to write the algorithm. Okay, so before writing the answer, you need to read the question carefully. Okay, depending on the mark only, you have to write the answer. Okay, so that's all. Tomorrow, next class, we can discuss the important topics in the second unit. Okay. Doubts ഉണ്ടെങ്കിൽ ചോദിക്കാം, ഇല്ലെങ്കിൽ നമുക്ക് അറ്റൻഡൻസ് എടുക്കാം. ഋഷാൽ, ആദ്രാനിൽ, അമയ, സൈന, ചന്ദന, പ്രതുൽ, ഷസ്, അതുൽ, അനുശ്രീ, അതുൽ എ, ഖദീജ, അമാന, ദിയ സി, സ്നേഹ, അമൽ പി, ദിയ ടി എം, വിനയ, അഭിജിത്ത്, രഖിൽ, ഫർഹാന, അന്വയ, ആര്യ, അക്ഷയ, സിക്ത കെ സി, അഭിൻ വി കെ, ഹസ്ന അബ്ദുൾ റഹ്മാൻ, അദ്വൈത്, ആദിത്യ, അഭിരാഗ്, ജയദീപ്, നന്ദന രാജ്, ഫാത്തിമ റിൻസി, അങ്കിത, ഹിബ, അനുശ്രീ, അനുശ്രീ യു, നസ്രി, അനന്യ, അഫ്ര ഫാത്തിമ, റീഹാൻ, ഫിദ, സരിക ജയരാജ്, സൂര്യനന്ദ, ഫാത്തിമ, ജുമീന. ഇത്രയും പേരാണ് ഉള്ളത് അല്ലേ? ഓക്കെ, അങ്ങനെയാണെങ്കിൽ നമുക്ക് അടുത്ത ക്ലാസ്സിൽ കാണാം. താങ്ക് യു.